when we are asked to divide these, first things first, what does that mean that we're going to do with all the pieces? Keep, change, flip. So this one's going to keep, change, flip. I also heard factor. That is also true. We are going to factor and keep, change, flip at the same time. Woohoo, party. So the first fraction keeps. So x plus 3 is still on top. I'm going to put parentheses around it to make it easier to spot stuff. Our denominator here, we are going to factor this guy. So I'm going to use my x frame. Our a value is 1, so I don't need my box. A times c, 1 times 12. B is 7. So pair of numbers, it multiplies to be 12 and adds to be 7. 4 and 3. So this one as a factored form is x plus 4, x plus 3. Then we had change our sign. And then our next fraction flips. So, this guy's going to become our denominator. How do we put that one as factored form? X plus 2, x minus 2. You absolutely can still use the x frame or the box to do that. A times c is negative 4, b is 0. You're still going to wind up with positive 2 and negative 2. Our last piece up here is going to be light blue. This guy. So we need to do our x frame for that guy. A times c is 6. B is 5. Pair of numbers that multiplies to be positive 6 and adds to be 5. 2 and 3. X plus 2. X plus 3. So first thing was to do our keep, change, flip, and factor absolutely everything. Now that we are multiplying, these smash together like this, and we try and simplify. What happens when we simplify? Which ones? X plus 3. I've got an x plus 3 and an x plus 3. I was going to say, hang on a second. Can I cross this one out? No. One on the top, one on the bottom. Those guys cancel out, but nobody else. That was way too chunky. And then, so we also can cancel out the x plus 2 and the x plus 2. Anything else? Nope. So our solution is x plus 3 over x plus 4 times x minus 2. That is our simplified solution, and we're going to leave it like that. You're not going to multiply it back out. Leave it in the factored form. Otherwise, you're just wasting your own time. Leave it in factored form. It'll say in the instructions to leave it in factored form. I guarantee you I'm going to have somebody waste their own time and multiply it back out. Don't. Leave it as a factored form. Okay? So then we're going to look at 24. We'll probably also do 25 just because we have plenty of time. And then we're going to do these graphs tomorrow because they're annoying. All right. So what we're going to do is we're going to look at this graph and we're going to read it. It may help to have our transformation form here, so I'm going to write that up here. That is not where that starts. Y equals A over X minus H plus K. And we're going to start with looking at our picture and finding our asymptotes so that we can find H and K. So I'm going to zoom it in on our picture real close here. There we go. So let's look at this vertical asymptote. What value is the vertical asymptote on? -2. Is that X is stuck at -2 or Y is stuck at -2? So that's x equals -2 as my vertical asymptote. What is this guy? Y equals, because my y is stuck at -4. That's my horizontal asymptote. That also helps us see our h, because x equals h and y equals k. That tells us what our h and k are. So we can look at these equations here. When you have something like this and you're trying to match the equation, go ahead and do it by crossing things out to rule things out. So if my h is -2, what's my denominator gonna be? X plus 2. So I know it's not gonna be b, and I know it's not gonna be d. Oh, nope. I know it's not gonna be I, sorry, x minus 2. I know it's not either one of those because it's not this -2. That's how I know it. If my k is -4, what's going to be on the end of my equation? -4. So it's not going to be d. So we can do this kind of by a process of elimination. I know that the equation is going to be this guy because it's the only one left. When it's asking if this graph has been reflected over the x-axis, what they're asking is it in the pluses or is it in the minuses when we would graph these? It's in the plus. So has it been reflected? No. Nope, so I know it's not that guy. E says this has not been reflected, so I'm going to go ahead and pick that one because I know it's in the positives, not reflected. C says this graph shows an exponential function. Is this an exponential function? No. You remember what this one's called? Called a rational function. Because fractions are totally rational. All right, so then for option F, I'm going to come in and zoom in. -1, -3. I want to know, does this graph go through the point -1, -3? Yeah. It goes through that point right there. That's that guy. It goes through. So yes, it goes to the point -1, -3. Totally cool. Is the h value -2? Yes. Is the horizontal asymptote y equals -4? Yes. So when you have these big select all that are true, look at each piece individually because it could be all of the texty options. It could be some of them. We got almost all of them in the right column. So look at them individually. And it doesn't matter how many points it is. That's not a clue as to how many you circle, so don't use that. Okay? Because usually what we do is we do like a half a point for each option. So whether you circle it or whether you don't circle it is going to be half a point. So read through all of them. And then let's do 25 and we will do graphy stuff tomorrow. So we've got that Jamar mowed the lawn in 20 minutes and Kevin mowed the lawn in 12 minutes. How long would it take them to mow the lawn together? How are we going to set this up? If Jamar can mow one lawn in 20 minutes, you can do one lawn in 20 minutes. And Kevin can do one lawn in 12 minutes. What do we do with their two rates if they work together? Add them together. And they'll be able to mow one lawn in some number of minutes, right? Some number. I don't know what it is, but it's a thing. What are we going to do with this? Well, we could try to, but right now they're not common denominators. And right now, so when we have this many fractions, we go a little bit. So let's multiply by what's on the bottom to get rid of all of our fractions. What we're going to do is we're going to find a common denominator. And that just means I'm going to take all the pieces in my denominators. We're going to have our 20, our 12, and our x. And I'm just going to multiply everybody by 20, 12, and x. 20, 12, and x. 20, 12, and x. Because then my 20 cancels out here, and we're left with 12x. My 12 cancels here, and we're left with 20x. And my x cancels here, and we're left with 20 times 12, which is going to be 240. I think. Yeah. 12x plus 20x equals 240 is significantly easier to solve than 1/12 plus 1/20. So what are we going to do now? Add the 12 and the 20. So we're going to get 32x equals 240. So how do we find out what x is? Divide. So x is, and we're going to, yeah. Let's say, oh, that's not my calculator, and it's full screen, so I can't get into the calculator. So I'm going to trust you. 7.5 is what you said? 7.5 minutes. If you get something that is longer than either one of them, something went funky. It's not going to take more time for them to work together. It should take you less time. Okay? Any questions on these guys? Tomorrow we will go through doing the graphs, because there's 3 graphs left in this chapter. And then module 10, we can do whatever questions you guys want. So flip through 10, and I'll let you guys pick which ones you want to go through. But you guys honestly did really well on the module 10 test. So if we're feeling comfortable with module 10, and we just want to have the rest of the Friday to work, I get that. Because your final in here is on Tuesday. So Monday, I'm going to collect your reference pages. And then Tuesday, you'll take the test. And that'll be it. I only see you 3 more times. Friday, Monday, Tuesday. And we'll see you Wednesday. We're almost at the end, y'all. Okay, so tomorrow we'll graph and do whatever you want in module 10. Monday will be your time to work and review. And then Tuesday's the test. That's just Tuesday's test. Reminder on that, the multiple choice portion of the final is on Canvas. You will need your computer. Have a computer. Bring it. Bring your charger too. Probably a great idea. I do not have an extra one. So this weekend, find your computer if you don't know where it is. Because you're going to need it. You cannot do it on your phone. Not just the rules, physically. You can't do it. There's the click and drags. They don't work on your phone. Gotta have your computer. Okay? It's not just because we don't like using your phones. They physically don't work. The pictures are too big. The click and drags don't work. You won't be able to see it all. So you cannot use your phones for the final. Period. End of sentence. Okay? So, do the thing. Keep working on this paper review. Work on the individual chapter reviews on Canvas. Work on the overall review on Canvas. Work on the Alex reviews. You have so many options. Do something to get yourself ready for this test. Oh.